everyone. Today, after a long break, I finally could resume this video series. And today I would like to build on our discussion of division. And if you remember, we had two interpretations of division. One was the sharing interpretation. This is just a recap so that you can connect today's discussion with the previous one. And the other interpretation was containment. And just to give one example of each, by sharing we mean is that if you have 6 apples and this division simples, let's say I by 2. Let's say I divide this by 2. So the sharing interpretation means that 6 apples shared among 2 persons will give 3 apples to each person. Yeah? Equal. Divide among 2 persons equally. So each person gets 3 apples. And the containment interpretation will be 6 apples and say you want to give 2 apples to each person. You don't know how many persons you have. So this can be given to 3 persons. Yeah. So another way of saying that is the group of 6 apples contains, you see containment, contains the group of 2 apples 3 times, so that you can give those groups to 3 persons. Yeah. So this is so far so good. What is not so obvious is what do we do in a situation like that. Let's say I have 1 apple and I want to divide this among 3 persons or 3 individuals. Now this was easy here, but here it's kind of difficult. So the only way you can do that is to cut that apple into 3 parts, and then each person will get a third of an apple. Now we need some notation to represent that answer. Yeah? So this is the operation, the division operation, and the result, which is a third of an apple. Yeah? If I cut it into 3 parts, that 1 part. So the standard notation is to put a line and put this 1 there and put this 3 there. Yeah? So this, and you literally say 1/3. 1/3. Let me read it here. 1/3. Or you can also say a third of an apple. And this leads to a new concept, because we need to distinguish between this operation and the result of this operation. And here is a name for this. This result, in a way we have discovered a new number. It's a new number. Yeah? It's not an integer. It's a fraction, you can call it. Yeah? It is a fraction of a number. Now this is very powerful, because now we can do something else. This was the sharing interpretation. So let me rephrase this question as a containment problem. So now I have 1 apple and I want to know how many times does this 1 apple contain the group of 3 apples. As a containment operation. So of course 1 apple cannot contain the whole of 3 apples, but it contain only one of those 3 apples. Yeah? So 1 of 3. Yeah? 1 of 3. So again, I get that answer. Again, my answer is 1/3. That in that case, it was 1/3 of an apple, and it is just 1/3. Yeah? So I can now turn this around. How about asking this question? Because I know the meaning of 1/3 apple. Yeah, this is a third of an apple. So I can say, let me replace these 3 apples with a third of an apple. Now look at this carefully. What am I asking? This is now containment interpretation, not the sharing interpretation. So you want to know, this is a group of apple, it's one apple, and this is a third of an apple. You want to know how many times this apple has a third of an apple. And you can know, you can see that this apple can be cut into 3 parts. So the answer is actually 3. Yeah. Read this again and say it out loud with me. An apple contains a third of an apple 3 times. So now we can conclude from these 2 examples something very interesting. Yeah. So provided that you understood the meaning of 1/3, a fraction, and how it plays in these examples, I can now draw 2 important conclusions. Only based on these examples, okay? So now we have discovered fractions, yeah? And so far, the type of fraction we have discovered is like that, like 1/3, yeah? You can also say 1 and 2 here, but let's focus on 1/3. So 1/3 is a new number and if you find it difficult what it means, the easiest way is to see how it behaves when it multiplies something. This can be anything, any number, any integer. You can say 15 or 12. So 1/3, what do I mean by 1/3? Is that if I multiply something by this 1/3, that would mean division by 3. That's how I need to remember. Yeah, remember, this is exactly how we introduced negative numbers. Yeah? So if I replace this by 1/4 of any number, 1/4 multiplied by any number will be that number divided by 4. Yeah? So I can actually, and by that last example, I also know is that this 1/3 has 2 properties. When it multiplies something, it can be seen as the division of this number. But when it divides something, if I divide something by 1/3, remember that example of 1/3 of an apple contained? So this can be understood as how many times this group contains this group. And that you saw was 3 times. So this is what we discovered here. A fraction is defined by its effect on an integer. So if it multiplies an integer, it is in fact a division. Yeah? And this should remind you. And when this divides something, when a fraction divides something, it is a multiplication. That is very cool. So just to make sure you know what I'm doing, if I now replace this with with 5, so multiplying something, some integer by 1/5 is the same as dividing that same number by 5. and dividing some integer by 1/5 is the same as multiplying that same number by 5. I think this is very cool. We can now move on. Let us do something else. Let us try, let's say I start from any integer and I do that thing. Yeah? And after I multiply this, which I know will be that's nothing new. But let's say after I am done with this, I now multiply this by something. Let's say I multiply this by 6. Of course. So look carefully. And this can be anything. So actually I am combining two operations. Yeah? First I multiply by a fraction, which is actually division. And then I multiply, this is the real multiplication. Yeah? This is only a multiplication which is giving me division. So in fact, what am I doing? I start with any number and I divide by something and then I multiply by that something. Now I can combine these two operations and I can represent this by a single operation. Actually there will be two. So this is something I can now invent a new notation that will be actually widening the definition of a fraction, because I know that first I divide by 5 and then I multiply it by 6. So if I use that same notation, the line, the division by something is represented by that, and it is followed by multiplication. So you have to read it that way. Now this is also a fraction. So now a fraction is just a bar with an integer there and with an integer here. And how do you interpret this? You interpret this by what it does in multiplication. So the meaning of this fraction 6 over 5 is divide by 5 followed by multiply by 5. Yeah? So division followed by multiplication is actually what we mean by fraction. Now we can, another interesting thing, let me remind you that one of the interpretations of subtraction was comparison, yeah? If you remember. Comparison. And comparison, one way of doing comparison was to subtract, like A minus B. Yeah, you want to know the difference between A and B. You can also use division to compare two things. Yeah? So this same A over B can also be used as a way to compare the two things. Now let me give you an example. Let's say I have 4 apples and I have 3 apples. Yeah? This is really easy, very easy, is just get 4/3. Yeah? This was easy. Let me replace this apples with oranges. Yeah? It's difficult to interpret. So that, remember the two interpretations of division, the sharing interpretation and the containment interpretation. Nothing works here because you see, we are just comparing apples and oranges. And even more, let me just give you another example. Let's say I'm playing matches and I'm comparing my wins. Let's say I have 4 wins and I have 3 times I lost to my opponent. So I'm just comparing wins to losses. There is no sharing, there is no containment. Yeah? But it is still a valid operation. So it is wrong to call it a fraction, because a fraction was motivated from that sharing and containment. So mathematicians prefer to call this number a ratio. Mathematically it's the same thing, but because you're not using sharing and containment, you're just comparing two things. So it's just a different name, yeah, a ratio. So now the upshot of all this is that whenever you see A over B, no, sometimes I will just call it a ratio, sometimes I will call it a fraction. Now fraction is, if I see this as sharing or containment, and in other words, I see is division. So then I will call it a fraction, yeah, with all the examples. But if I use this A over B, I know mathematically I'll be doing division, but the purpose will not be sharing or containment. The purpose will be comparison, yeah? And you don't want to use subtraction for comparison, you want to use division for comparison. So when division is used for sharing or containment, you call it a fraction. But when division is used as a means to compare things, you call it a ratio. Now the cool thing about this ratio is that you can have different numerator, the denominations can be different. So for example, here you can say 3 apples, and here you can say 2 persons. Yeah? And in a way, if I make these numbers nice, if I now say 6 apples, and if I say 2 persons, and if I see this just as a comparison, I'm comparing 6 apples to 2 persons. But if I now invoke that interpretation as well, because I know 6 over 2 is 3, now what is that 3? Now that 3 is not a pure number. Because this is a ratio, a comparison of apples and persons, this 3 is in fact a ratio. So it is apples per, because you cannot lose this ratio. Yeah, that is, and this is why I was avoiding this in the beginning, because this concept is quite advanced. So that's it for today. You learned how to develop the two notions of fraction and ratio. This is one interpretation, this is another interpretation, and when you don't want to bother yourself with these interpretations, if you just want to see this as a mathematical operation without caring about the interpretation, so without an interpretation there is another name, and that is also important to know. That is called a quotient. So whenever you see A over B, if you don't want to bother yourself about what it means, just call it a quotient. If you want to interpret this as a sharing or a containment, then that is actually a fraction. You can even call it that way. If you want to use the quotient to represent some comparison, you call it a ratio. The mathematics is the same, the meanings are different. Bye for now.